Okay, like I said in the last video, we're going to be reviewing this old project that I made. This is a thermostat. You plug this into the wall, you plug your heat lamp or something like that, or fan, into this guy here, and you can set some parameters on these buttons and it'll act as a thermostat. So I'm going to plug it up and see if we can figure out how it works. Again, I didn't label these buttons. This is not by any means a production finished product. It's just finished in that it's an enclosure, and it does what it's supposed to do. I use this in a chicken egg hatching project. So let's plug it up. Plugged up and energize. Ooh, oh, it works. Still, I don't know why it wouldn't, but still. Bring you around here. See if you can see this. Okay, press mode to start. It says, what's mode? I think this is mode. So we'll press mode. Okay, heat. T-stat 70. Okay, I believe this. I think, yeah, this is the mode button. I think this changes the thermostat setting. Yeah, okay, and then down. And what does this guy do? This. Let's see here. If I hold this button and then I press this, yes, this changes it by 10 degrees. That way you don't have to scroll all the way. So let's see my maximum settings here. Okay, 250 degrees at the top end. And minus 40 at the low end, Fahrenheit. Fahrenheit here and these here, you know, backwater United States still use them outdated systems. On the end is this is a, what the hell is that? This is a TMP36 temperature sensor, and it comes in that the TO92 package, like BJT transistors, and I've just heat shrinked it onto the end of a 3-wire cable here. This is a stereo. It's a stereo cable, and plugs in here. So here's a stereo speaker cable, stereo headphone cable. So as I plug that up, let's see what the reading is. Current temperature. The CT means current temperature, and the power is currently off because it's way above the set temperature. So I'm going to plug this in, plug it back in. Okay, it says the current temperature in here is 74 degrees. Whatever the thermostat said, this is just like a thermostat at your house. So if the thermostat is set at minus 40, any temperature below minus 40 will cause the power to come on to this receptacle here. So let's get more reasonable here. Let's get more reasonable. Set it at a more reasonable temperature. No, that's unreasonable. 79 degrees. Power is on. Let's see here. 74 degrees, power is off. If I set it for 74 degrees and it's 75 degrees, the power is off. 75 degrees, power is off. It's power on. I believe, I don't recall, but I believe there's a 2-degree hysteresis that I programmed into it, I think. But let's see, let's go to cool mode. If I press mode again, we go into cooling mode, which reverses everything. So if the temperature setting is 76 degrees and the current temperature is 74 degrees, which is less, the power will be off. But if we heat this up above 76 degrees, the power will come on. Yeah, I'm just holding it between my fingers. Okay, and as it cools back down, see, I've released it now. It's cooling off. Come on, cool off, damn it. Okay, well, I guess there's not a 2-degree hysteresis built in. It just goes off. I'm gonna heat it back up again. On. Okay. So let me see if let's demonstrate this with something. Let me let me grab a fan or something and we'll demonstrate this. Okay. I couldn't find a fan that I could easily bring in here, but what I did find is this old lamp here. So the lamp, as you can see, is plugged into the device. Okay, you can see the set temperature 76, so it should come on any second now as the current temperature drops. Current temperature drops. I'm waving this around trying to cool it off. So I warmed it up to 80 degrees with my fingers. It's steadily cooling off. So when it gets below 76, the lamps should kick on. It's at 76 now. The lamp should kick on. Hold on, wait for it. There it is. Huh, it's weird. Still at 76, but kicked on. Okay, it's dropping. It's doing the in-between. It's fluctuating. 75 now. So, yep, lamp kicks on. If I put it in a cool mode, it should go off because, or the current temperature is below the set temperature. Right, so let's raise that temperature up. See, if we pretended like this was a fan, if this lamp was a fan, raise this temperature up. There it is. So the fan kicks on. There we go. Alright, so that's the basic gist of it. Let's take it apart and see what makes it tick. Sorry about the greasy fingers. This is actually being recorded while I'm working on my magical mystery bus, which is to come in another video, but taking breaks from working on that because I am no mechanic and it gets me extremely frustrated. I take breaks from time to time. I figured I'd make this video. So every now and then you're going to see greasy hands and greasy fingers and things like that. So that's not the norm, though, believe me. Don't judge me. Okay. Oh, what is this mess? Okay, I got you. Alright, let's go over this here. See what I've got going on here. Oh, yeah, I remember this guy. Okay, here's what we got. I'll use the screwdriver as a pointer so you don't get to look at my greasy, nasty fingers. Okay. So power comes in into a solid state relay, and that guy is rated, it's got 3 to 32 volt DC input, we'll turn it on, and 24 to 380 volt AC input, as in usable power. I don't know how many amps it's rated at, though. I don't know what it'll take. But anyway, power comes in here, and we got the ubiquitous wire nut connections for the power connectors. Let's see here. So it looks like, okay, yeah, I've got a neutral connection that goes into this power supply. This is just a USB phone charger. That's what supplied my 5 volts to the microcontroller circuit here. So yeah, we've got a neutral connection for that. We've got a hot connection for that. So yeah. Oh no. The hot connection comes through the switch, is broken through the switch, and then yeah, out to the relay. Yeah. Hot connection to the switch, out to the relay. Okay. Then let's take a look. Let me unplug this guy here. So that disconnects 5 volt power. So we can get a better look at that. Yeah, just an old USB phone charger. to supply 5 volts. Let's take a look at our board here. You know, it's not as bad as I thought it was going to be. I was thinking that it was going to be much worse. Looks like, okay, I got a couple pins. I got some pins here for going out to the temperature sensor. So it's a headphone jack. Got an electrolytic. Why do I have that electrolytic capacitor on it? Oh, that's for yeah, that gets a lot of the noise out of the line. That's right. This thing was all over the place before I added that capacitor, and that the temperature would swing wildly before putting that capacitor across the leads. So there's a potentiometer for something. I'm not sure what that potentiometer does. I don't remember. Got my wires tied down with just little pieces of copper wire. And jumpers and solder traces. This isn't as bad as I remembered it. I seem to remember it just being just a gooey mess. So it looks like all the brains are on the other side of the board. So I'm gonna have to pull that take that screen loose to make it happen. Okay, I've got that loose, taken apart. I got the screws out of the front. But I wanted to notice here you have there's apparently a ground pin. I think it's ground. I believe, yeah, I would probably want ground to jump all my switches out. And then the switches themselves, 1, 2, 3, and 4 is a four wire connection here that takes it into the microcontroller on the other side. And here is the other side. The other side. That is that should be like a ATmega 328. Let's see if I can see it myself. Yeah, that's an ATmega 328. That's the same as the that's the same microcontroller, 16-bit microcontroller that comes in the Arduino Uno. Yeah, there's the clock crystal. I'm not sure what that pin header does there. Yeah. So that's pretty much it. I programmed basically an Arduino Uno. It's basically what that is. As a matter of fact, that's what I did. I programmed the chip on the Arduino Uno using the USB input. I just unplug it from this socket, plug it into the Arduino Uno, and upload the code, and then plug it back into here. And oh yeah, the potentiometer is for backlight. The potentiometer is for the brightness of the backlight, so I could adjust that. So a neat little project I threw together. I was thinking it was going to be a lot more sloppy than it is, and I'm surprised that it's as good as it is. Now, sure, some of you are sitting out there thinking, man, this thing is really sloppy, but hey, for a guy with hand tools and, you know, no real equipment to work with, no shop per se to do it in, that's pretty good. Yeah, so ground comes through, neutral passes right through. There's our microcontroller telling the relay to turn off and on. It's connected to the board there. So obviously, yeah, that's on the back side of the microcontroller. So everything stays pretty close to home going into the microcontroller there. This damn thing won't stay out of the way. Stupid USB cable. Yep. Yeah, that's a lot better. I just didn't expect it to be that good. And you know what? We could repurpose this, seeing as how we have the input pulled out of the board. There's pins underneath these headers here, or underneath these connectors here. So we have the input pulled out, just a single input. we have a control lead on the output. We have power. We have a display for whatever we wanted to use, and there is plenty of other inputs available from that microcontroller. ADCs and PWM pins. We could repurpose this. Well, I mean, or I could leave it alone. I mean, it seems like a fine tool to use. It has its use. I don't know. I might be able to make this a multi-use tool instead of just a thermostat. I could put a selector switch in there that switches its function, so we could have multiple. Yeah, we could put multiple devices. We could plug multiple different devices depending on what mode it's in or what you selected. We could plug in a different sensor. It could be a light sensor or a humidity and temperature sensor or just anything. Really, anything that could send information into the ADC on the microcontroller, and if we wanted, we could get the display. Yeah, we could write. There's plenty of room left on the microcontroller, so depending on the mode that you set, the display screen would also change to reflect the new information that you're trying to read. So yeah, it could be a voltmeter, a magnetic field sensor. Man, this thing could do anything really. Now that I'm thinking about it, it doesn't even have to switch an output. It could still switch an output, or it could just be a digital display for whatever you wanted to use. That's interesting. That'll definitely be a project that we're going to look at in the future. So let's just shelve this guy again, put it to the side. I don't know what those pins are for, though. I'll have to check the sheet and see what pins they're hooked to on the microcontroller and why I pulled them out like that. But yeah, this would be I think this would be a fun project to get back into. So as usual, like, subscribe, comment, criticize, tell me how stupid I am for doing it the way I've done it. But this worked very well for the purpose that I built it for, and it still works. You know, just taking it out of the shop years later and plugging it in, it still obviously does what it's supposed to do. The temperature's pretty accurate. It was reading the temperature in here very accurately. So let's get cracking. See you on the flip-flop.